Well, hello and welcome back in some way, shape, or form. I am going to present to you guys now the slides from chapter 7. So enjoy my voice over the slides. And remember that every day from 2 to 3 p.m., I will be hosting a virtual office hours in Zoom. And you are free to join in if you have any questions about things or if you just want some human contact. I'm going to be hanging out. So answer questions, maybe do a little of a bunch of things. Um, all right. So here we go. We are going into following our 2 weeks off after chapter 6. And we are going to start chapter 7, which is, as you can see, sampling how to estimate the frequency of behaviors and beliefs. Later, probably tomorrow, or Thursday morning, I will be posting up the 2x2 article and talking through that with you guys before assigning the next assignment, which is your seed article critique. Because I decided essentially write the paper in the proper format that I'd always wanted. And what I'm thinking of doing is having you guys figure out how to change it on your own so it's slightly different from everyone else. But we'll talk about that in the coming weeks. Right now, I present to you Chapter 7. So the learning objectives for Chapter 7, we are going to indicate that the population that a given sample might represent. We'll talk about what a population is versus a sample. We will define 3 sampling problems that lead to biased samples. Understand why a random sample is more likely to be representative and why representative samples have much better external validity to a particular population, rather than, as we sort of talked about previously in the class, just sort of going over to the auditorium and picking out 300 people because it's convenient. Those sometimes are called non-random or biased samples. So I'm going to explain 5 techniques for random sampling, which include simple random sampling, multi-stage sampling, cluster sampling, stratified random sampling, and something that we call oversampling if need be. I will also describe 3 types of non-random sampling: purposive sampling, convenience sampling, which kind of falls under that category of the people that are outside of the auditorium because there's 300 of them and they're all right there, so it's convenient. And something we call snowball sampling, because sometimes we don't have enough of a sample, so we need to ask people that we've already interviewed to interview others. I'll get more into that in a little bit. I'm going to explain why representative samples may be especially important for frequency claims, because remember, if you guys can think back all the way to chapter 3, we talked about how frequency claims with one measured variable, the utmost importance for that one is to be able to generalize to the population as a whole. So external validity is actually the priority of a frequency claim. So that's why it may be especially important. But there's also a lot of times in the real world where you can't get a random sample and you just may need to get a more convenient or unrepresentative sample to be able to do this for a frequency claim. We see this a lot of times in polls for who you might vote for president or, elections, things like that. It's not always easy and realistic to get a representative sample. So in those times, an unrepresentative sample is still better than nothing. And I will also explain why it's more important to ask how a sample was collected rather than looking at how large the sample is. I know that when we talked about from chapter 3, the idea of statistical validity, and what that tells us is that sample size and power and all of that, right? Effect size matters. But what we'll see at the end, by the end of this chapter, is that the idea here is that all things considered, how you got the sample is better than how many you got in the sample, because 50 randomly sampled is probably going to give you a better estimate than 200 people in a non-random sample. It's just not always easy to get that. So looking over the chapter, we're going to start with generalizability. Does the sample represent the population? And we're going to, in the second half of this chapter, interrogate external validity, asking what matters most. And the answer to frequency claims is external validity matters most. Now, when we're talking about a correlation or an experiment, true experiment, causal claim, then we know external validity isn't as important, or doesn't seem to be as important. I guess it really depends. But in a frequency claim, which we've been concentrating on, it is of the utmost importance. So generalizability. Does our sample represent the population? Before we get into this, we have to understand specifically what a sample is and a population. So we're going to talk about populations and samples. We're going to talk about when a sample is biased and how to best obtain a representative sample for these techniques, the probability sampling techniques, the 5 that I talked about in the overview. And sometimes, again, in the real world, we don't always have that option, so sometimes we have to settle for an unrepresentative sample, and so I will talk about 3 of those bias techniques. First, this was a snapshot from about 8 or 9 years ago, probably, from USA Today. I normally click to a link that has a poll question, but really, there's no need to look at a different poll question right now. I could ask anything. The most relevant one on this day and age is, to what population can we generalize the results from a presidential poll? At this point, it seems fairly obvious it's going to be Trump versus Biden. So who are people going to vote for? So you can really replace this with any poll you want, but we're asking what population we can generalize results. Well, we know that in a presidential election that the people that get to vote are members of the United States of America. So in this case, our population is any voting American. And that could include people from Guam, that could include Puerto Rico and other US territories. When we look at how many people are answering a poll, we look to that as sort of what we call a census. And the 2020 census is actually going around right now. So when you're looking at how many people answered the poll, you're not going to get everybody in the United States, everybody that votes. Not everybody has a computer, not everybody knows about these polls, not everybody cares to be a part of it. So the question is, from this many people, can we generalize to the population as a whole? And the answer is yes, we can generalize, but how well can we generalize? One of the things that we'll kind of dissect is these types of polls, are they more biased than we actually think? And I tend to take everything with a grain of salt when it comes to polls, because one of the first things that we think about is that these polls are, you're self-selected. When you see these polls on a news website or the USA Today website or things like that, it's only the people that have access to those websites that are going to answer that question. And if it's on Fox News, it tends to be leaning towards Republican opinion. If it's on MSNBC or maybe even CNN, it tends to lean a little more liberal, democratic, right? So sometimes we just have to take these things with a grain of salt, because what about the people who really decide the election, meaning the independents that could go one way or the other? Do they actually contribute to these polls? We don't really know the answer to that. And therefore, although the polls, some of the polls can be better than others, I still take them all with a grain of salt, because we don't really ever have the right generalization for this. So short answer, yes. Long answer, what I just said. Sorry. So when we look at the hierarchy, we have the population, which is the entire group that we are trying to estimate, the entire group that we're looking to represent. The sample is a small portion of that group that we're trying to generalize to the rest of the group. And then we have this thing called a census. I know the census that comes out is asking people how many people there are in the United States. The definition of a census is when everybody in your sample is everybody in your population. So let's say the population of our 92 class is all 42 or 43 students that are in it. If I were to randomly take 10 of you like I did for the Stroop task, that was a random sample because I picked everybody at random, and everybody in the class that was there that day at that time had an equal chance of being picked, and I randomly just picked 10 of you. That was a good sample of the population. If I were to have tested all 42 or 43 of you, I don't remember how many are on the roster now, close to that, then that's what we call a census. So when the sample and the population are the same number, if you test or poll everybody in the population, we don't call that a sample, we just call that a census. So a census is when the population is all tested or polled, and every single person in that population gets to participate. But the main question that we're asking is, what is our population of interest? Well, in the example I gave you for voting, it's everybody in the United States, or at least everybody that's eligible to vote, over 18 and has proper US legalization status and things like that. So that's our population of interest. Looking at this chart, we can see that there are 5 representative ways to sample people that we call representative. In this case, the sample says in a representative style that all members of the population of interest basically have an equal chance of being picked. Just like I randomly picked 10 of you in class for the Stroop task, everybody in the sample has a chance of being picked. When we talked about surveys and handing them out, I mentioned going little by little to each classroom and randomly picking 4 or 5 people in each room, in each building, on each floor, in order to get a good sample of the population of ELAC, right? We still don't have the whole population. We have people that take weekend classes. We have people that take online only classes, which is everybody now, obviously. Bad joke, and not really meant as a joke, but you get it. So we have a lot of people that won't be part of this. But if everybody has an equal chance of being picked, we can even go randomly on the online courses to do this. That is what we call a representative sample. So we have 5 types: simple random sample, systematic sample, cluster sample, multi-stage, oversampling, and what we call stratified random sampling. But that's not always feasible. And a lot of these polls that we see online and things like that, that we're taking very seriously, are based on bias samples. So whether it's convenience, purposive, snowball sample, or like I talked about with these polls online, self-selected samples, yeah, these are more biased ways. So in this case, some types of people are systematically left out simply because we can't get a representative sample, or maybe people are being lazy. That is always a chance. So when we look at coming from a population versus representing that population, we have bias samples and we have representative samples. So let's take a look at the population of interest and then try to understand why a technique is biased, and an example of one that's representative and why it's representative. So if you are voting in a state primary, kind of like we did for Super Tuesday a few weeks ago for the Democratic or the Republican primary. To see who the main candidates for president will be, here's our population of interest. If we're looking at the Democratic primary, it is all Democrats in Texas for the Texas state primary. A biased way to sample is to go to the Texas Democratic Convention when it's going on and just taking or recruiting people sitting in the front row. Why is this biased? Normally I would ask you that question, but I don't have the luxury of doing that. So I'll answer that question. It's biased because you're only getting the people that are in the front row, and those people may have paid a lot more money or may be super, super interested in the Democrat Party based on the fact that they're sitting in the front row. This is not representative of all Democrats in Texas, right? So this sample may be supercharged Democrats, and it is not representative of all Democrats in Texas. A more representative technique for sampling people, if we wanted a sample of the population of Democrats in Texas, would be to obtain a list of all registered Texas Democrats from some sort of public record, City Hall, or the government office in the Capitol, and calling a sample of them through randomized digit dialing, randomly picking out, I don't know, 200 or 300 people from this list in no particular order, and calling them and asking them their opinion on who they're going to vote for. This way, everybody in that list has an equal chance of being picked. Whereas in the front row, it's just the people that are sitting in the front row, and they may be inherently different than just a random person from a list. For pediatricians, if you wanted to do a survey on pediatricians, a biased way of doing that, a lot of times people like to go face to face and do these things. So you may only be hitting up a certain few clinics one day a week or a couple days a week. So those days that you go into those offices, you're asking only the pediatricians who are working on that day. But that is really not representative of all pediatricians, even in that office, because there are some that may have, let's say today's Tuesday, we'll go in on a Tuesday. And some pediatricians have Tuesdays off. So you're not getting the ones that aren't there. How would we get rid of this and make it a more representative sample? Again, some sort of list of licensed pediatricians, and we would select them using some sort of random name or random number generator. If we assigned each one of them a number and then just said, okay, number 612, I'm going to interview you, and then number 1013, I'm going to interview you, and then number 4, I'm going to interview you. So that is a much, again, more representative sample because everybody on that list has an equal chance of being picked. It's completely random. What about students who've taken a class with Professor A, or in this case, Dr. B? And some of you guys have taken more than one class with me. So at least you're probably a little more comfortable with this format than the others because you've already had me. Maybe, maybe not. A bias sample would be only the students who have written comments about me on some sort of online website like Rate Your Professor. And no, I don't go on there, but maybe I should. Hopefully you guys are saying nice things, the ones that do. But if I were only to choose the students that said something nice about me that I knew of on an evaluation or on a Rate My Professor type website, that would be a biased sample. And of course, I'd probably only choose the ones that said nice things about me. Just saying. Still even more biased in that case, right? A representative sample would be obtaining a list of all of my current and former students and selecting maybe every 15th student for the study. You don't have to do it randomly. You can just go by, every so many students on a study, every third, every 15th. You can roll dice, and whatever the number comes up, you can go with that, right? All of those are more representative because, again, if the list, especially if it isn't in alphabetical order or anything like that, everybody has an equal chance of being the quote-unquote 15th student. So bias sample is only the students that have written comments about me, because there may be, whether they are good or bad, they may have, I may have evoked some sort of emotion that the other students didn't get. Whereas if I just go through a list of every 15th student, everybody again has an equal chance of being picked because we don't know, unless that list is in alphabetical order, right? And even if it is, I don't have to go with every 15th student. So everybody has fairly equal chance of being picked. That's why this is representative. So the question is, when is a sample biased? When it's not representative, right? So the easiest way to get a biased sample is just getting a hold of the people that are easiest to contact. I gave you the example already in class. Yes, I miss it already too. Of just getting people outside of the auditorium because it's really easy. They just got out of some sort of rally or demonstration or theater performance or something like that, and they're all right there in one place. So it is just easier. It is just more convenient to be able to sample those people who are standing there, and my job is done, right? We can just go with people that, especially if you have sort of biases towards what you want to see. But you don't, and we don't always have the luxury of being able to obtain these types of lists, right? So the last thing that I talked about was that we can't always obtain these lists. Who's going to be able to have access to the records of all the Democrats in Texas? Who's going to be able to get a list of all of these types of things, right? So sometimes we don't always have that option. And it's just convenient to get enough people to make this poll valid. So looking at the 2010 congressional vote, we are looking at opinions that are based on the type of telephone use. Looking at the number of people sampled that had both landline and cell phones, we got about 50%. Landline only was 52%, with a difference of about 2.5%. In this case, if we think about it, landline only is going to be people that don't have necessarily cell phones. People that still have landlines tend to be older, or businesses. In this case, what we find is that you're going to be biased then towards people who may own businesses and people who may be of an older generation, which may not be representative of the population of voters, right? We're trying to invoke the young people to vote just as much. For Democrats, there's about a same 2.5% difference, but if you look, landline only for Democrats is about 39.4%. For landline and cell phone together, 42%. We don't see much of a difference between Republican and Democrat, but there is a difference in the numbers. For other don't know or independents, maybe it's about the same, 8.5 to 8.4. And the margin you can see is much bigger in landline only than in both landline and cell phone. So there's a pretty big difference there. This is based on Pew Research. So basically, the bottom line of this is that it may be easier and more convenient to do things a certain way, but it's not as representative to the population. This is what we call a convenience sampling. Other ways to get bias samples, all of these polls that I've just been talking about, is basically sampling only the ones that invite themselves. And there is already bias behind this because you may not want to answer a poll question if you don't count for this poll, or if your answer may not be one that you think is desirable. You can just choose to sit out. So self-selection means that people can choose whether or not they want to participate in this. And that in itself is a biased method. So if we look at the graphic on the left below self-selection, it says U.S. parents link their involvement with achievement. Communication between schools and parents seen as key to student achievement. So we see that 99% of people who took this poll agree that frequent communication is important and impacts student achievement. And that is a really good number when you see this. But what about the parents that didn't participate in this survey? There are plenty of parents for school children that have no communication with the teacher. And maybe they don't know enough about education, maybe they don't care enough, and they hope that the school just takes care of everything. They are not going to be part of this sample, right? They would not choose to answer this question because they are very hands-off. 85% believe children are appreciative of their involvement in school, of parental involvement. 94% want to be more involved by using the internet. 34% have online access to their children's academic information. Again, there's a lot of people that may not want to. 52% are most interested in grades. 85% want more progress updates. But again, that's 85%, 94%, 99% of the people that have volunteered to take the survey. Looking at the one on the right, this makes it even more abundantly clear. If we're looking at gifted children, right? This is on about.com from a few years ago. As you can see, the total number of votes was about 7,356. It was exactly 7,356. So it was about 7,400. Was your child an early reader? What we see is no, and the child did not want to learn any faster than other kids, 3%. Of course, that's going to be the lowest amount of people on this poll. No, but learn quickly in school, 7%. Yes, before age 3. Those are the really gifted ones, right? You see the biggest percentage there in that one, 2,374. Let me explain that in a minute. Yes, my child was able to read before age 4. We have over 2,000 there. And just below that, at 2,039, yes, before age 5. Well, guess what? Those people who have a gifted child, kind of like myself with Dr. C, would be very eager to answer this poll and be counted in this, right? Oh yeah, my kid's gifted and I definitely want to take part of this. People whose child is at a normal pace and maybe hasn't read before age 5, the no and didn't want to learn any faster, or no but learn quickly, are a much smaller percentage represented in this poll than the top 3. Why is that? Because those that don't have a kid that's gifted, or those that don't have a kid that read early, probably feel embarrassed and they don't want to be counted, even though they're anonymous in the poll. Like, yeah, I'm not going to be part of that. My kid's slow, or my kid's this, right? They're just like, yeah, this is not the poll for me. I'm not even going to answer it. So it is very biased with self-selection, because those that are most motivated to answer this question are the ones that actually have the gifted children or the early readers. Now, this population has nothing to do with people that don't have children, so those people wouldn't be included, because the population of interest is people with children, or, as the poll would make it seem, gifted children. So this is where the bias of self-selection really stands out. And I can also apply this to those presidential polls, because people who are right-wing leaning tend to go towards the Fox News type website, so they're only going to select that poll. Those that lean left are going to go to the CNN or the MSNBCs. So the ones in the middle, I don't know how well those are represented either, because again, it's only those people that are self-selected. So these bias sampling techniques, we just talked about convenience sampling. In this way, purposive sampling is a method where people are purposely looking for specific spots. So if you want to ask people about exercise, purposive sampling is only going to places where you tend to see people exercising. In this case, you're handing out your survey in front of gyms, not anymore because they're closed, but you would be handing them out in front of gyms, or maybe at parks where you see people playing sports. But you're not going to just randomly go anywhere and ask people, hey, how much do you exercise? So purposive is doing something with an agenda. If you are wanting to know about people's feelings of marijuana and you just go and stand outside of dispensaries, you're going to get a very purposive, biased sample, right? Looking at, the idea of legalizing marijuana, because the people who don't want to legalize it are not going to be hanging out at a dispensary, right? So that would be purposive sampling, and that would, be having an agenda. And although it's nice, because you do want to know about exercise and things like that, kind of like the Mr. T problem from that last worksheet, it is not the best way to get a representative sample, but you probably get more people participating this way. Self-selected sample we also went over. So the last one that we have to talk about that's a bias sampling technique is called snowball sampling. And a lot of times this is done because we just don't have enough information. In a snowball sample, you basically get a sample of people, and once you interview them, you ask the question of, do you know anybody else that might want to answer this question or might be able to take this survey? The reasoning behind this, let's give you an example, is let's say that you want to know about online video games and you really only grabbed through this people I already interviewed. Since you guys are already online and you're connected to other people that play online games, would you mind giving me a few names and contact information for people that can also take this survey? So what you're doing is you're snowballing. You're taking a few samples that you got and you're asking them to give you more information, and they tell their friends and they tell their friends and so on. Okay, sorry. I was getting a little carried away there, but that's what we mean by a snowball sample. So you are in essence um, getting more people in a biased way because you're getting them from people you've already interviewed, right? So it's not people that have an equal chance of being picked. It's like, oh, I know this dude or this girl that plays, and here's their information. So convenient sampling, getting people because it's convenient. Purposive sampling, going to places where you know people are going to be specifically there for a specific thing, like a gym or a dispensary. Self-selected, online, people that really want to contribute or talk about it will. But those that do not will just abstain from that. So is it a representative sample? Not by a long shot. That's why I don't generally trust these political polls pretty much ever. Although some can be, I guess, more accurate than others. I take them all with a grain of salt. And snowball sampling, I collect a few people and then they give me more contact information for others. So these are your bias sampling techniques. Obtaining a representative sample is a much better way to do things because we guarantee, even if our sample is smaller than a bias technique, that it is more representative of our population. So we use what we call probability sampling by taking some sort of probability measure. In simple random sampling, we can do something which I usually use a lot of times when I am picking you guys as teams. If you guys didn't have a team already, of course, that's a moot point for this class this semester, but we use either a name or a number randomizer. So I can go online and I can put everybody's name in the class into a randomizer, and what it will do is randomly generate names. So the first four names will be the first group, and the next four names will be the next group. And each person has an equal chance of randomly being picked. Or I can use a number randomizer like here. You can see this for simple random sampling, right? This could be if we obtain one of those documents of Democratic voters in Texas or something like that. And so looking at set number one, we see 8, 519, 543, 186. So whoever's names are next to those numbers are the ones that we will contact for the poll. And so this is what we call simple random sampling. We can simply randomize or just randomly pick people. Other types of probability sampling are systematic sampling, where you can pick we talked about this for every 15th name in a book. If we have rows in our classroom, we have 8 rows of 6 for 48 chairs, something like that. So I can also take 2 dice and I can go, all right, let me roll the dice, and what comes up is a 3 and a 4. So 3 rows over and 4 people back okay, third row, fourth chair, you're going to get tested or get a survey. And then I roll the dice again and it says 5-1. So, okay, fifth row, first seat, you're going to get tested. Things like that. So that would be systematic sampling. Cluster sampling is a way of randomly choosing people sort of in a cluster, but again, everybody still has a chance of being picked. So if we wanted to get a poll of, I usually use schools in this case. I know everybody's home now, so we could do it this way. We could take, in a cluster sample, I choose one school, ELAC, and from that school, I randomly select 100 people. So that would be sort of a cluster sampling. I can even randomly choose one class out of a school to do something because it's randomly picking. Everybody has the same chance of being picked. In an elementary school, I'm going to randomly choose a third grade class, and of the 4 third grade classes, I'm going to choose Mrs. Perez's class because it was just picked at random. So that's a cluster sample. In multi-stage sampling, we have a bunch of different, it's basically a cluster of a cluster. So we decide we want to go that there are, in LAUSD or something like that, we'll just say there's 100 schools. Of that 100 schools, we will choose 10 schools to represent. And from those 10 schools, we'll randomly take 50 students from each of those schools. So basically, multi-stage is a cluster of a cluster. We start with a cluster, 100 schools. From those 100 schools, we take a little cluster of each and sample them. That is multi-stage sampling. In stratified random sampling, we're trying to keep, I guess you would say, the numbers or percentages of a population and keep them the same. So in Monterey Park or in East LA, what we see is that the demographics of the community and the demographics of the school are fairly similar, where we see about 85% Hispanic, Latino, or Latinx. We see about 12% Asian. We see about 4% African American, maybe 3% Caucasian, and 3% mixed or something like that. So if we wanted to sample the people of ELAC or the people of Monterey Park or East LA, we want to stick to those numbers. So maybe we would get if we wanted to randomly get 100 people, if 85% are Hispanic Latinx, we would get 85 people from the Latinx Hispanic community. We would get 12 people from the Asian community. We would get 4 people from the African American community of that city, and keep the same percentages. And that's what we get 100 people to sample and you're keeping it stratified and you only have 3 Caucasians, is that really representative? 3 people, is that really representative? No, you probably need to do something we call oversampling. So even though majority of your sample should be Hispanic Latinx, only having 3 mixed race or 3 people that are Caucasian or 4 people that are African American is not going to be representative enough in some sort of survey. So you need to oversample and at least get 10 people from each of those um, demographics in order to get at least enough people to qualify for a specific response. So oversampling is a form of stratified random sampling where you basically just take more than the demographic, but just to make sure that it's enough to be represented. And of course, we talked about systematic sampling in a systematic way, Whereas simple random sampling is where we're just randomly picking names or numbers. And you can do this a lot of times when I have students do their experiments in class. What they do is they just pick numbers out of a hat. So if there's 4 groups, if it's a between group subject, 2 by 2 is 4 groups. And I would have 4 numbers 1, 2, 3, and 4 in a hat. And as you walked by people's rows, you would just have them pick a number. So if you have 40 people, 10 would be in group 1, 10 would be in 2, 10 would be in 3, 10 would be in 4. So that is another way of systematically sampling. So sometimes we combine techniques. Sometimes we can, once we take a convenient sample of people, maybe we only count, 15 or 40 of them, whatever it is. So we can sort of sometimes combine biased and representative samples. The best way to generalize to the public, to the population of interest, of course, is using a representative sample. But in the real world, like we said, it's not always feasible. So when we look at random sampling, which is what we just talked about, versus random assignment, which is something we'll talk about in chapter 10, I just wanted to make sure that people understand the difference between them and that they don't confuse them. So in random sampling, we're trying to increase external validity. We're trying to increase generalization to the population of interest. In random assignment, that's where you're randomly assigning people to groups. So I would randomly assign you to the studying or no studying groups. So this is only used in causal claims and experimental designs to randomly assign participants to their groups. This is to increase internal validity because we don't want the group that studies to already be better at studying before we give you study material, or the people that aren't studying to be worse at exams simply not because they don't study, but because maybe they're not good test takers, or they're not prepared, or things like that. So random assignment we're going to talk about in the context of internal validity. Random sampling of a population is for external validity, and that's the one that's important here. So again, in the real world, we don't always have people that read these polls. We don't have people that go to these websites. In that case, we have self-selection because those are simply the people that come across this. A lot of times we don't have time and money, and in this day and age, we aren't allowed to leave our houses, so we may have to settle for convenience sampling. That doesn't mean that, it just means it's a little less representative. It doesn't mean that it invalidates our study. It's just not as good for external validity. So we have convenience sampling. We talked about the propositive sampling, where you're just going to places where you know you'll get people for this topic. Snowball sampling, where you get your few people and then you ask them to give you names of people they know. Or quota, which is sort of an idea of kind of like stratified random sampling, but in a biased way. In a quota sample, you know that you need to get a certain amount, up to a certain amount of people for each maybe demographic or each category. So once you get, you're still doing it in a biased way, but once you get 10 African American people, you're good. And once you get 10 Asian Americans, you're good. You've met your quota. Are you getting them randomly, or are you just going to places where you know that they will be, right? In quota sampling, it doesn't matter. It's a biased technique. So finally, looking at external validity and asking the question, what matters most? Well, we know that external validity is the top priority in a frequency claim, but sometimes the top priority may not be a representative sample, because in the real world, we don't always have that luxury. When we're talking about testing and surveys and all of that stuff, and in research methods, we like to simulate in an experimental setting when we can control for a lot of things. In the real world, it's really hard to be able to control a lot of things, right? So we're going to look at non-random samples in the real world, as well as non-random samples in research studies. And I know that when we talked about statistical validity in chapter 3, we tended to say that the larger the sample, the better it is, because the bigger the sample size, the bigger the effect size. And as a review from statistics, bigger sample size, bigger effect size means more power. And statistical power is the ability to detect a greater effect, to actually see the effect. In this case, larger samples are not necessarily more representative. They are if they were not taken or not recruited in a biased way. In a random sample, it's much better and much easier to generalize that to the population as a whole. So, looking at this sort of graph or table, we're looking, if the percentage is estimated on a random sample size of 2,000, your margin of error is very small, plus or minus 2. 1,500 people, it's still pretty small. 1,000 people, it's still at 3%. But what happens when you get less people? 500 people, it jumps to 4%. 200 people, it's at 7%. 100, 10% chance of error, right? Remember, if we go by alpha equals 0.05, we want 5% or less in our experiments. If you only have 50 people, it's plus or minus 14%. That's a lot of margin for error, right? The margin of error, as you see at the bottom, there's a little note that says estimates in this table are based on a 50% polling result. That's half of the population. And even that generates plus or minus 14% all the way to 2%. So, thinking about it, in the way that we talk about this, having 50 people in a random sample is still better than 200 people in a biased sample. So when we say larger samples are not necessarily more representative, that's what we mean. If you grab 200 people coming out of the auditorium for an anti-marijuana campaign or something like that, it's not going to get you better results than randomly picking even 50 people that are coming out of different classrooms from different buildings. Even if you get 1 or 2 from each class, that's still going to be better at 50 than 200 people in a biased way. So let's do some practice here. During a recent US election, the news media interviewed a group of women in Florida. Although opinion polls, of course, strongly supported the liberal candidate, even though it is Florida, these conservative women were still optimistic that their own side would win. One woman said, "I don't think these polls are very good. After all, they've never called me. Have they called any of you ladies?" So is this woman's critique of polling techniques appropriate? Why or why not? Well, one of the things that you guys may do when you see polls at home during sports games or things like that is say, well, I've never contributed to this poll, so how would they even know? Is this critique appropriate? Well, yes, I would say it is appropriate because it's not based on necessarily a random sample. Because I was never asked to be in this poll, I never saw it, or it could be people that are self-selecting, right? So we know that there is biases here. We know that this doesn't seem very representative. I've never answered that question, right? So this woman is kind of saying, like I say, take these polls with a grain of salt. Imagine you're planning to estimate the price of the average book at your college bookstore. And don't look at the new books. It might be a little expensive. The bookstore carries 13,000 titles, but you plan to only sample 200 of those books. So you're selecting a sample of 200 books, recording the price of each book, and using that average of the 200 books to estimate the average price of the 13,000 titles in the bookstore. If we assume that the bookstore can give us access to some sort of database that lists all 13,000 titles, and maybe they're in alphabetical order, maybe they're randomly placed on this list. So this example was adapted from a study by Cosby in 2007. Not that Bill Cosby, okay? That's C-O-S-B-Y. So let's get that straight. So based on this information, can we answer these following questions? What is the sample in this study and what is the population of interest? Well, in this case, the sample is 200 books from a bookstore. The population of interest is all the books in this bookstore. Are you still with me? I hope so. How might we collect a simple random sample of the books? Well, what we could do is, if the sample of 13,000 is numbered, we could just randomly pick 200 books from this. Or we can do it in a systematic way. We can just go to every 20th book or something like that in the list until we get to 200. What I would want to do is kind of randomly go from lowest price to highest price and back, so that we have an equal amount of books that are in the lower range, equal amount of books that are in the more expensive range, and an equal amount of books that are in sort of the medium price range. And that way, that nice random sample at least gives you financially an equal amount in low, medium, and high prices to be able to average. How might you collect a stratified random sample in this case? If we know that a certain percentage of books exist, how many of these books are psychology books? How many of these books are math books? How many of these books are English books? We can look at the number of classes or the percentage of students in each of these classes from ELAC in any given semester and say, or given year, and say, let's get if 20% of students are taking psychology classes, we'll get 20 books from, or in this case, if it's 200, we'll get 40 books from psychology. If 60% of students are taking math classes, we'll get 120 of those books from, or something like that, from 60% of our sample from math books, and 30% from English books and things like that. How might you collect a convenience sample? Well, shoot, let's just go to the first bookshelf, or we'll just take that list, and whatever the first 200 books are, we'll just use those because, hey, easy. Systematic random sample. Again, every 15 or 20 books. Cluster sample is to take maybe a certain page. We'll just randomly select the 7th page of this printout, and we'll just take books from there. And if that's only 100, then we'll select another cluster, the 13th page, and then we'll take all the books from that list. And a quota sample would be meeting a quota. We'll try to get maybe 10 books in a row from each page until we get to 200. I believe that is it. So rather than breaking up Chapter 7 into multiple lectures, I figured I would just do it in one. And I'll let you guys give me some feedback and let me know, would it be better to split it up into 2 lectures? Does it make any difference? Because it's easy for me to just kind of ramble through it in one lecture and then wait for it to batch and post it to you guys. I look forward to hearing back from you. And if you want, I'll see you in the office hours around 2 o'clock. Maybe not today, but maybe sometime this week or next week. All right. So thank you guys for listening, and I hope that we can talk soon. Bye-bye.